Okay, so this is the solution key for the first worksheet we did on Thursday, where we were computing specificity and sensitivity. I won't bother going through these formulas. We did this before. Although there is an interpretation I'm going to talk about a little bit later regarding specificity and sensitivity. Okay. And so I'll just redo the first problem quickly. Notice we're given a table here, okay? We want to figure out here what the specificity and sensitivity are. So we know the number of people that have the disease and don't have the disease. Then we administer a test and we look at their test results. And from that we tabulate the following numbers here. So this is given. So we go back and we basically use the definition of sensitivity. It's basically the percentage of time a test works correctly when you have the disease. Okay? So we take the number of times when you have the disease, the test works correctly, that's the numerator, and divide it by the number of people that have the disease. We get that ratio from the table. We add up these two and we get 194 people don't have the disease, by the way. We compute this decimal out to 5 places. We round it to 4, and then we write it as a percentage. Okay? For sensitivity, it's the same sort of deal, except now we're looking at how well the test works when you don't have the disease. So we find out the number of people that don't have the disease with the correct test results is 355. And the total number of people that don't have the disease is 410. Take that ratio, again write it as a decimal out to the 5th place. Notice that this is a 5, so we round the 4th place to a 9 and write that as a percentage. Okay, in problem 2, okay, we're given the sensitivity of the test. We're told that it's applied to 450 people, all of whom have the disease. And we want to know how many of those 450 people are also going to have a positive test. So we want the number of people with a positive test and the disease. And notice we can start from the definition of sensitivity, and the reason why we'd like to do that is because we know 2 of the quantities in this formula. We know the sensitivity is 0.93, and we know the total number of people that have the disease is 450. So notice when we substitute this into the formula, there's only one thing we don't know, which is what we're after. The number of people who have the disease and end up with a positive test result. And so, plugging these values into this formula, we get this. And I'm going to solve for the number of people that both have the disease and test positive by multiplying by 450 on both sides. Okay. And then since I'm interested in this quantity, I'm going to put it on the left-hand side. And we're going to get an answer of 418.5. Now, we're talking about numbers of people, so we can't have half a person, okay? And it's a question of how you round. Normally we round up, but in this case we want an estimate. And so we're going to round to the nearest decimal place, which in this case just happens to be rounding up, okay? Because the 0.5 rounds the ones place to one higher value, taking it from an 8 to a 9. And that's our final answer, 419. Now the third example is actually very similar, except now in sensitivity. Instead of sensitivity, we're using specificity. So we're told the specificity of a test is 87%. Notice that whenever we work with a specificity doing math, okay, we have to convert the percentage to a decimal. So I'm going to write 87% as 0.87. And what I'm told is that there's 300 people that don't have the disease. They're given this test, and we want to know how many of those 300 people that don't have the disease also will have a negative test result. So isn't that the number of people not having the disease and a negative test result? Sure. So notice I can use this same sort of formula as I did last time, except now using the specificity and the fact that it's a ratio of the number of people who don't have the disease and a negative test result to the number of people that don't have the disease. So I know the specificity, I know the total number of people who don't have the disease. Substituting them into the equation, I get the following. And I can easily solve for what I want, which is the numerator by multiplying both sides by 300. And what I do, I get a nice round number of 261. And that's my final answer. Now the last problem is kind of a gamish of a couple of different problems. Here we're told the sensitivity of a test, the specificity. We're told that in this country we're interested in, 30% of the population has a disease. Well, that's the prevalence. Okay, whenever I know the percentage of the total population that has a disease. And I'm finally told the total number of people in the population for this country is 10,000. And I want to fill in this table. The question is, how do I do that? Here I've already filled it in, but how did I get these bold-faced numbers? Let's write down the given information first, okay? We're told the sensitivity is 95%. I'm going to do mathematics with it, so I'm going to rewrite that percentage as a decimal, right? Specificity was 60%, so I'm going to write that as a decimal, 0.6. The prevalence is the percentage of the total population having a disease. Well, that's 30%, which I'm going to write as 0.3. And finally, the total population is 10,000. The first thing I can get here is the total number of people that have the disease. Because I know the percentage of the total population that has a disease, and I know the total number of people in the population. I take that product, and I'm going to get 3,000 here. Okay, so that gives me the first number in the table. And if you're not sure about how I got that, think about what the prevalence is. The prevalence is the percentage of people in the population that have the disease. So it's going to be, the prevalence is equal to the number of people that have the disease divided by the total number of people in the population, right? And I'll find out the same sort of results if I take that train of thought. Okay. Now I want the number of people that have the disease and test positive. Well, isn't that exactly like the problem that we did in example 2, where we knew the total number of people that had the disease, we knew the sensitivity, substituted those in, and got the number of people that tested positive and had the disease. And when you go through the math, you find out it's 2,850. So that gives me the second number right up here. Well, the last number in this column is easy to get at, right? The number of people who have the disease and test negative, because I know everything in this column has to add to 3,500. So this minus this gives me 150. So we're done with the first column. Now I'm going to do the same sort of thing with the second column. Notice that 3,000 people have the disease in the population of 10,000. So I get the fact that there's 7,000 people total who have the disease very easily. And now I can do the same thing I did with example 3, right? Because notice that I know how many people have the disease. I know the specificity. And so doing the same sort of manipulations I did, in example 3, I find out that there's 4,200 people that have the disease. Okay? Don't have the disease and have a negative test result, sorry. So I get this number right here. Okay, last but not least, I want the number of people that test negative and don't have the disease. Well, again, same sort of thing. These two numbers have to add up to 7,000, so this must be 4,200. And that completes the table. Okay, good. Now I want the NPV and the PPV. And notice we usually use a formula for this, okay? But when we have the table, we can compute it from the table also. Supposedly this is the whole population, okay? And here's how I want to think about the PPV. Let's think about it for a second. It's the percentage of times that a person who tests positive has a disease. And this is important. If this isn't obvious, you should stop the video and think about this a little bit. This is an important fact. Okay. So what am I going to do? Well, I'm going to take the number of people who test positive, the number of people that test positive and have the disease, and I'm going to compute this ratio. This is the percentage of times that the person that has a positive test result also has a disease. Put these numbers in, and of course I get the number of people who test positive by going to the table, right? Now I'm going to add up this row right here. This is the total number of people that tested positive. It's the number of people that tested positive and had the disease, and the number of people that tested positive and didn't have the disease. Okay? And I take that ratio, compute it out to the 5th decimal place, round it to the 4th, express it as a percentage, and I get that. Now the NPV is the same sort of thing. It's the percentage of times that a person who has a negative test result does not have the disease. Okay? It's the probability that a person who has a negative test result doesn't have the disease. Well, again, I can write it as this ratio. Even though we had a formula, it's this ratio when I actually have a table. I go to the table, I find out the number of people had negative test result. Well, that's easy because there's 10,000 total. There's 5,650 with a positive test result. So there must be 4,350 people with a negative test result. Okay. So I take this ratio, compute it out to a decimal to the 5th place, round it to the 4th, and express it as a percentage. Okay, so that's the end for the problems on the first worksheet.